Hello students, in the previous lecture we have seen the general form of the wave equation. तरंग गति का व्यापक समीकरण क्या था? d2y over dx square minus 1 upon v square into d2y over dt square equals 0, where y is the displacement of the wave from its mean position and y is dependent on x and t at any instant. Here is a very beautiful and very interesting question to all of you guys. बहुत ही खूबसूरत क्वेश्चन आपसे करने चल रहा हूं. How could you say here v stands for the velocity of the wave in this medium? वेव इक्वेशन में यहाँ पे जो v है ये इस वेव की वेलोसिटी है. आप कैसे कह सकते हो? Yeah, you can make an argument. Since we have got the dimension of the velocity, v equals under root t by mu, tension in mass per unit length. So definitely v is the velocity, but it may be something else. May not be the velocity of the wave. But I say, here v is the velocity of the wave of propagation in this medium. Definitely I can prove it. The way you do that, you ask yourself, what is the nature of the solution of this one equation? Means what kind of function y is? What function do you think will make important role here? Dear friends, y can be any function. Y can be any function you want, but only through this combination x plus minus vt. Y equals f of x plus vt, or y may be g of x minus vt. आप x प्लस माइनस vt के रूप में कोई भी कॉम्बिनेशन आप लोगे, y का फंक्शन वो बनेगा और सेटिस्फाई करेगा इस इक्वेशन को. यू कैन राइट डाउन y इक्वल्स e टू द पावर x माइनस vt and that will satisfy the equation, I guarantee it. Suppose I take y equals x minus vt, y equals x minus vt. Then choose a single variable, say z. मान लो कि z एक वेरिएबल है, सिंगल वेरिएबल है जो x माइनस vt के इक्वल है. z इक्वल्स x माइनस vt. Obviously here, since y equals f of x minus vt and x minus vt equals z, means y equals f of z. Y equals f of z. Now next we have to prove this one. Y is the function of x minus vt, any kind of function. So just you differentiate y with respect of x. That is dy over dx. You can say y is the function of z. So first you differentiate y with respect of z, and next you differentiate z with respect of x by the step differentiation. That is dd z of f of z into dd x of z. Okay, that is dd z of f of z into ddx of z. Z equals x minus vt, so dd x of x minus vt. If you differentiate this one x minus vt with respect of x, you will get answer 1. ddx of x 1, ddx of minus vt 0. That is 1 minus 0 means 1. So you multiply this one by 1. That is dd z of f of z. Here is second derivative. So again you differentiate with respect of x. Take the second derivative. So without wasting time, I am writing here d2y over dx square equals d2 f of z over dz square. d2 f of z over dz square. Note it down. Next, differentiate y with respect of t. Differentiate y with respect of t. That is dy over dt. Y is the function of z. So first you differentiate y with respect of z. That is dd z of f of z or y into dd t of z. dd f of z over dz multiplied by dd x of z, z equals x minus vt, that is dd t of x minus vt. If you differentiate, you will get dd t of x 0, dd t of minus vt, that is minus v, 0 minus v, multiply by minus v. You will get dd f of z with respect of z multiplied by minus v. Next, here is second derivative with respect of t, so you differentiate twice. Therefore, the second derivative, I am writing without doing the process, d2y over dt square equals d2f of z over dz square into minus v whole square, that is v square. Now if you multiply here by 1 by v square, 1 by v square, so 1 by v square will cancel out. Your answer is d2f of z upon dz square, the same value of d2y over dx square. Check, the both values are same. If you subtract these two, you will get the answer 0. Means our assumption was correct. So y can be any function of only through this combination x minus vt. Y can depend on x and can depend on t, but through this combination. Suppose you take y equals e to the power minus x minus vt square, and if you plot this one, you will get a wave this type. Yes, if you change at t equals 0, you will get this one. At t equals 1, you will get this way, and at t equals 2, you will get this way. The bump is shifted by v after every 1 second, means v is the velocity of the wave of the propagation in this medium. So here v stands for the velocity of the wave. Thank you.